Okay. Hi everyone. Welcome to the DevTourFest Cloud Native series. And today we'll be talking about the day 2 operations, the second session. So in the first session, yeah, we talked about various aspects like monitoring and then also CI/CD and taking the data backups. And in the second session, we are going to touch about certain aspects which are kind of extension of our first session. Just a brief introduction about myself. Um, my name is Gaurav. I am in the part of product management in SAP. So working as a product expert and technology evangelist, mostly helping the customers succeed in their cloud native journey. So whenever they are going to build some kind of cloud native applications or extensions with SAP solutions, I'm helping them using or choose the right tools so that yeah they can have their architecture got right, and then also they can then succeed in building or solving their problems. Okay, so the outline for today's session looks like a bit this. So we'll talk about the optimization. So we will not directly jump into optimizations. We'll first try to understand what does it mean when you provision a Kyma cluster, what does you pay for, what are the costs, and then we start talking about how you can efficiently utilize or have your setup in such a way that you are optimal from a cost perspective and from a resource usage perspective. We'll also talk about Istio from an optimization perspective. So we will not be going into details about the whole story about Istio, what Istio is and what it can do. That is maybe for some other day, but for today we are just focusing on when you use Istio as a sidecar along with Kyma, by default it is provided there. So what you can do further to ensure that you are optimizing the resource usage, you are basically using your memory and CPU in efficient fashion. So that was mostly about the optimization part, and then we'll talk about the security part. We'll see like the various aspects of security, how you can even restrict the access for your apps using the STO authorization, talking a bit about the secret management, and then also talking a bit about Kubernetes security contexts. And last but not the least, we'll look about the governance aspect from the Kubernetes perspective or the Kubernetes RBAC, because when you are going to give some access to your developers or even setting up some kind of access for your CI/CD pipelines, it is it is important to understand that what kind of access you can give and what are the implications of those accesses. And the last topic, a very small one, but really important because I see it many times that people are not aware of that. We'll see like where you should look for when you are trying to get some more information about what is going to be coming new in Kyma, what is the next feature, what is a major update, what's a major upgrade coming. So how you can stay yourself up to date with this kind of information. So what are the links, what are the resources you should look for when you are asking yourself these questions. Okay, so let's go further. So let's go to the second slide. Yep, so we'll start with understanding the Kyma sizing and cost part here. I'll just quickly actually go to the estimator because it looks a bit better in the actual browser. So you can also see that what's happening there. So I'm just going to open the estimator here. So this is the Kyma estimator. So whenever you want to use Kyma from SAP BTP, you can always come to this estimator. It will give you an estimate about the cost for your Kyma cluster. So how much you will end up paying for your Kyma cluster. You will see that when by default you come here, there is a default cost of 1,449 capacity units. So it will translate to your corresponding currency. So for example, if you are in Germany or if you are using Kyma from the EU region, it will be translated, one capacity unit is €1. So you'll be paying around 1,449 euros per month. But what do you pay for as a part of this schema cluster? So essentially, you pay for this base configuration, which is nothing but how many virtual machines or nodes you are going to use for your schema cluster. So here you can choose the size. So by default, for this much amount, the default amount, you will always be provisioning minimum of 2 virtual machines and each having a size of 8 CPUs and 32 gigabytes. So basically, you are having this much of compute where your workloads, your components, as well as the Kyma components are deployed. So Kyma components take around 50% of the compute. So around 8 CPUs and 32 gigabytes is basically used by the Kyma components. And for your workloads, you are left with the rest of the part, which is like the 8 CPUs and 32 gigabytes for you. You can also decide to maybe go for a higher size of virtual machines if you want to go for maybe something like 16 CPUs or even up to 48 CPUs. It will depend upon what kind of workloads we are going to deploy and what kind of resource requirements they have. So it's very important to understand and have kind of an idea about your applications, what are their sizing needs, and then you are in a better position to decide which kind of virtual machines better fit for my use case or my scenario. Okay, so compute is a one part of the story. The other part of the story is basically the storage. So by default, this cost already includes 224 gigabytes of storage, but this is already used by the Kyma component. So if you go down there, it must be kind of mentioned somewhere here. If I look for this, yeah. So this 224 gigabyte of storage from the Kyma base setup can't be used for custom deployments because it is already reserved for the Kyma component. So they are going to having this much of usage for various Kyma components like Prometheus, like some other components that require some kind of storage. So they already end up consuming this much. So in case you want to use some storage, you can always do it in increments of 32 gigabytes. So if I increase it here, you can see that around 13 capacity units get added for that. So it's not a major component, but yes, you also need to keep that in mind. So this basically is how you should always be targeting the cost estimations for your Kyma cluster. This should always be the starting point, just to understand like what cost you are going to be incurring for running a Kyma cluster of a specific size or for specific needs. Okay, so let's go back there because now you understand how you want to estimate. But let's also just quickly look at how this kind of this compute is distributed or how it is being used. So essentially, what you are paying for is these two nodes. So by Kyma itself, by default, is you can think of it as like a Kubernetes cluster, but plus a lot of extra components, as we have seen in the last session. So you have a Kubernetes control plane, which is not a part of your cost, but you basically pay for these two computes. And this is where your workloads and Kyma workloads are running. So basically, these are two Kubernetes worker nodes. I'm seeing here for 8 CPUs and 30 gigabyte, but it can be for any size. And similarly, there are some storage for the Kyma components, and you can also consider having some storage for your workloads. So this storage plus these two or how many nodes you deploy, they together make a part of your Kyma cluster cost. So, and this is how kind of they are distributed. So it's not like that there is one separate node on which all the Kyma components are running and other one has your workloads. No, it is all together distributed on both the nodes directly there. Basically, it's like the Kubernetes taking care of doing it in an intelligent way that wherever it can find the best fit, it will put your components or Kyma components there and start running them. Okay, so the other thing to understand is when you are provisioning a Kyma cluster, you will always be specifying these kind of configurations. You are saying that there is an autoscaler max of 10 and then a min of 2 and then the machine type. So the machine type correlates to what kind of machine size you're looking for. For example, we saw that there is a 8 CPU, 16, 32, and corresponding memory. So it will be depending upon this machine type. And then the min and the max is how many virtual machines it can auto scale. So depending upon as you start deploying more workloads, you might end up, or the Kubernetes might end up hitting the limits for these two virtual machines. So then it will need more resources. So if you are not reaching the max, then it will start basically adding more virtual machines or more nodes and then start deploying the workloads there. So this is basically the autoscaler for the virtual machines or nodes. That's how you can configure it. But if you have reached your max, then it cannot scale anymore because then you intentionally don't want to scale beyond that value. So that's where it will not be able to deploy further workloads if there are some further workloads to be deployed. So yeah, always keep an eye on that. How much is the current usage for your virtual machines and how much space is left or how much it can maximally scale to. So if you are already at the limits and you see that or basically you have an idea that there might be more workloads getting deployed or more applications getting auto scaled, then it's a good idea to go and update the max value so that you don't hit into the problems that the workloads are not being deployed. Okay, yeah, so the cost itself, they are a function of the machines and the storage. So yeah, we already talked about that bit, but yeah, it's kind of just again to stress, it's very important. Okay, so that was about the cost part, but now how does it translate to what's happening at my workload level? So basically, in Kubernetes world, there are three main aspects as far as the resources are concerned. So the first one is the usage, which is basically the exact usage which your application is doing. So for example, your application might be consuming half a CPU or consuming maybe 1 GB of memory. So that is like the actual usage. And then there is something called as request. It is basically how much resources you are reserving for each application. You might end up using maybe 1 GB, but you have reserved maybe 2 GB for your application because you foresee the needs that it might reach up to that point. And then the limits are up to what maximum value it can reach. So you see that in my case, so this is basically the overall value for the whole cluster, but it is coming from each every application that is deployed there. So it's kind of a sum of all those applications that are running inside the cluster. So I can see here that the usage is like decent, around 21%. It's for the CPU, by the way. And then the requests are around 68%, but the limits are really, really many times higher, which is like, okay, fine, because not every application is going to at the same time hit the limits which have been configured for that. If that's the case, then you should definitely go back and then resize or set up the correct request and basically for your application so that they don't go into some kind of a clash here. But essentially, it's fine because as long as not all applications are going to be start consuming that many resources at the same time, because limits are something that application can go up to, not that it must go to. That's very important to understand. Yeah, so just talking a bit about the request and the limits. So just one example. So there is a example application that I'm looking at here. Here I can see that I have set my request to 100M, which is like zero point 0.1 CPU and a memory of 128 megabytes, and then the limits to up to zero point 0.2 M and memory of 256 megabytes. That's something that I set. And apart from that, there is something that we set from the Istio proxy sidecar that is running along with your container. For that, by default, Kyma is setting up a CPU reservation or request of zero point 0.1 CPU or 100M and then a memory of 192 megabytes. But the limits can be up to 1 CPU and 1 GB. So this is basically set by Kyma. So the sum of these two is what your actual application or pod is consuming. So there is a value set by you for your business application, and then there is a proxy that is attached to your application. So you basically kind of consume the sum of these two values. So that's kind of important to understand, because if you just take your calculation into account, then you are not calculating it in the right way. You're always missing what the Istio proxy can consume. So again, just to revise, request is something that is the guaranteed resources that you will get. So this is something when you deploy an application on Kubernetes or Kyma, this is the amount of resources that Kubernetes will reserve for your application. So that's why your actual usage or your cost, they will always be dependent upon the request, but not the actual usage. So if you are using maybe 1% of the resources, but your requests are 80%, then you are using 80% of the cluster, or basically you are consuming that many virtual machines that come to the 80% of your resources. So that's quite very important to understand. And the limits are basically they are like the max usage that you are allowed to have. And if you try going beyond the usage, you might see things like out of memory and CPU throttling. So very important to understand that when you are setting the limits, you should understand if your application starts getting more load, there are more users who are trying to access the application, then you should always go and see that whether you are seeing those problems, and then also go and adjust the limits and the request for your applications appropriately. So sizing, in my honest opinion, is always a continuous exercise. You can size your application maybe at the start, but as your application improves, it evolves, and also you see the different kind of a behavior from the user perspective, you might always need to revisit it. So it's not a one-time exercise. It's an exercise that you need to continuously keep on doing it to ensure that your applications are always running in a healthy state. Yeah. So Very important that you understand the requirements for your applications. You should be able to have a decent idea that how much memory and CPU is required for your application to run in a correct fashion so that it can handle the request with the maybe some kind of acceptable latency numbers. There are also certain settings that you can do at the namespace level. Now, there are things like, or there are scenarios where, for example, you have a dev namespace where you're only deploying some workloads for development. So it might make sense that you do not want these developer workloads to consume too many resources. So that's where these things like resource quotas and limit range can come into picture. Using these things, using these semantics from Kubernetes, you can limit how much a particular namespace can consume, and you can also start setting the default behavior for your applications. So in case you want to try out these things, just have a look at like the Kubernetes documentation. You can see what does a resource quotas, what does limit range means. It can be useful for controlling the usage so that it doesn't go out of control. It doesn't go like beyond the limits or beyond expectations. Yeah, so just giving an example, like how does your resource allocation look at the node level? So basically, what we saw in the previous diagram, this overall picture, it is nothing but the sum of each node. So here you can see that there can be a CPU usage of a certain value, and then there could be a limits that could be quite higher. Same thing goes for memory. So it's very kind of interesting to always go and check at your node level to see that if it is close to 90 or 95% of the usage, either in CPU or memory, then ensure that you have maybe another node scaled up so that the workloads can be then further deployed if new workloads are getting scaled up or need to be deployed. Then yeah, so ensure that you don't go beyond 90-95% of usage. Otherwise, you might go into scenarios where yeah, your workloads are not running correctly. Yeah, so just like how much your compute is getting used, that's basically how much resources are you are reserving. So that's very important to understand. You see there that my requests are around 68%. So it means that I am consuming about 68% of this particular node. I'm not, even though my usage might be really low, but the ultimate indicator or ultimate decider factor here is how much request or how much resources are being reserved here. Yeah, so that was basically about like what does all this usage and limits means. But now second, there comes the question is that, okay, I know that I have application that consumes certain amount of resources, but I don't want to have like a really a large value given to it so that it can always work correctly. So there are other ways that where you can even do a efficient scaling of your application. So in Kubernetes, there is something called as a horizontal pod autoscaler. So essentially what it does is that if you have basically an application and it has maybe one replica, which means that it has one pod, that's fine. But at some point, it might make sense that for handling large volumes or large loads, you can set up more replicas. So using something like a horizontal pod autoscaler, you can configure it to autoscale. So you can have different criteria. You can, for example, have a criteria of a CPU usage beyond a certain threshold, or you can have a basically a usage for a memory, for example, by default. So essentially what you can do is you can create these kind of rules that whenever my CPU usage is reaching 50%, I want to spin up another replica so that I don't go beyond 50%. That's just an example, but depending upon how your application is supposed to behave, you can have another value configured there. So based on this, whenever you see high volume, for example, during Black Friday events, whenever there is a sudden surge of a load, you can ensure that your applications are auto scaled. And after that, whenever it is getting basically cooled down, the volume is less, then it can scale it back to the lower values so that you are able to keep your business up and running when the load was high, and you are able to save the cost back when the Black Friday or the load is going back to normal. So you can kind of have a mix of both of these. Okay, so let's now talk a bit about the Istio and what kind of optimizations we can do from an Istio perspective. So just basically telling a bit about what does what happens with the Istio sidecar. So essentially, whenever you deploy an application that has a Istio sidecar, it it basically brings this proxy that is sitting next to your application, and all the traffic that goes, either the traffic that is incoming or traffic outgoing, it is going via this proxy. So we have seen the benefits of the Istio in the previous session, where you see that a lot of metrics are coming out of the box from Istio itself. It's happening because this proxy intercepts all the traffic and then it generates all the metrics for you. So that's kind of really useful. But at the same time, as we have seen now, that when you deploy this proxy, it will also consume some resources. Yeah. So we saw that it consumes around 100 M and 192 megabytes as a request, and then it can go up to one CPU and yeah, 1 gigabyte as a limit. So the question that comes is, um, this is basically the default configuration, and it can go up to 1 gigabyte and one CPU. And the question is basically, it's basically too much of usage, and how I can optimize it. So maybe that's where we need to understand why it is that much. And then the second thing would be that once we understand why it is configured to consume that much of resources, let's try to see if we can somehow control it. So the why part is really interesting because yeah, I also once I started asking myself this question, then I was able to kind of research about that bit, and then was able to find out, okay, yeah, that's the reason. That's why it can go up to that much of reason, that much of resources. So the why part is basically every application that is a part of the Istio service mesh by default from Istio, it is aware of all the other applications. So this awareness, this knowledge of all the other sidecar proxies comes with a price. It means that every proxy needs to store that much information about all the other services, all the other microservices running in your cluster, which might not be required. But that means that if it is going to store, for example, if your Kyma cluster has 1000 microservices, now imagine every application storing the information for all the other 999 services. So maybe that's too much of information, because then it consumes that much amount of memory and also CPU for processing that information. And same thing from the control plane, it is going to send that much of information. So it means that a lot of CPU and a lot of network IO that will be consumed. That will mean that the changes will be propagated slowly, and then as your services or the number of services will increase, your sidecar usage will increase. So just to give an kind of image idea about how does it look like, so it looks like this. So if you have a lot of microservices and everyone is communicating or supposed to communicate with each other, then you're kind of having this kind of a mesh. So that's where it might consume, you see the limits are really high. That's why it might consume up to one CPU and 1 gigabyte of the resources. But that is not always the case. We most likely do not want this kind of a behavior until and unless we have an application that is actually supposed to know about all the other applications are running in the Kyma cluster. So a typical Kyma use case is that you might be building your applications in a single namespace. You might be building like based on your different teams or different scenarios. You might be doing it in one namespace. You might be sending some events for some kind of asynchronous workflows, or you are interacting with other applications in the same namespace. There is like hardly, we have seen the examples where people build some application that is communicating with maybe 50, 30, or 60 applications, because they're only restricted to maybe 4 or 5 microservices. So if you just look at like from a idea perspective, this is how it looks like. So there could be an example app. It might be calling 2 other applications or maybe 4 or 5 applications in the same namespace. It might be sending the events. So it will need to interact with Istio because it need to get the information from Istio there. And you might be accessing some services over the internet, but that's more like a typical Kyma use case. And for that, the default Istio behavior is something that most likely you do not need. That means that if you do not need the default Istio behavior, so there is a good possibility that you can somehow declare that, hey, I don't want that kind of exposure. So maybe send me some less information. That's what I need, and then I will just use that for my business scenario or my workloads. So for that, Istio kind of provides a way actually. So there is basically a concept of a sidecar object where you can declare this intention that what kind of a exposure or what kind of egress traffic you require from your workloads or your services. So it's basically a way of saying that, okay, I know that there are 500 or 1000 services in my Kyma cluster, but I am only interested in the 5 services. So I want to just work with those 5 microservices. So I just need to know about those 5 of them. So this comes with something called a sidecar object. So you basically declare this sidecar object and you say that my egress traffic, the traffic propagating from my application, is coming to those hosts. So basically they are in the same namespace. So the dot star slash means that all the applications in the same namespace. And then I can say that all the workloads in the Istio system namespace, basically the Istio components. And then if I want to publish some events based on some kind of asynchronous workflows, then I can say that I want to also know about where I want to publish the events, basically, which is this event publisher proxy. So you can create it with the YAML, or you can also create it via the dashboard UI. So if maybe I can just go quickly there and show you an example if I have already there. So let me just see if I have one of the namespaces where I can show you. So just going to the namespace, going to the Istio section. So in the Istio section, there is something called as sidecars. So yeah, I have this one created. So here you can basically create the egress part for that. So here you can specify that what are my egress. So same YAML that we saw here, you can also do it via the UI also. But here you are declaring the intention that all the workloads in my this particular namespace, they are going to communicate with each other, or they are going to communicate with Istio system, or they are going to publish the event. So basically communicating with this service running in the Kyma system namespace. So you can also see that I don't need to only provide the namespaces. I can also provide a particular workload in another namespace. So that's also very important to understand. Yeah. So basically, when you do such kind of a declaration, you are always going to control or optimize the usage of the Istio resources so that they don't consume too much of memory and they also don't consume too much of CPU, which is again beneficial from the cost and the usage perspective. Okay, so that was about optimizations, and now maybe let's talk a bit about security. So I'm not going to cover all the security concepts because the security in terms of Kubernetes and Kyma itself is a very vast topic. But I'm going to kind of give you some of the or expose you to some of the major things that I feel are really important and critical to understand, so that they can also help you to build and run secure applications on the Kyma cluster itself for Kyma runtime. So the first one is basically about the Istio authorization policy. The whole idea that you can run multiple microservices in a Kyma cluster or a Kubernetes cluster is quite nice. But at the same time, you might not have the requirement to have all the microservices exposed to each other, because just for example, that if you're deploying some front end, it might not need to talk to the database. So there is no need to expose your front end to make an API call to database or talk to database. So you can control these kind of exposures by using the Istio authorization policy. So you can, for example, declare that I want to deny, or you can even have a allow rule. So you can say that I want to deny all the applications in the dev namespace, and then also I can do it at the operation level. So just an example, but the policy itself is quite flexible. You can apply it for a full namespace, or you can apply it for a particular workload, and you can also create very interesting rules based on your requirements. But the whole idea is that whenever you're deploying your workloads inside Kyma, always think about that this workload to who what other applications it should be exposed, so that they can make the API calls or they can connect to it. If it's a minimal, then always try to restrict the access by declaring it intentionally, so that you don't have all the applications just exposed there because they are by default that way. Okay, so the other thing that's really important and interesting is coming from the Kubernetes side. So it's something called the pod security context. Basically, this is the idea of declaring that when your pod is running inside a Kubernetes cluster or a Kyma runtime in this case, what kind of privileges and access it has. So again, we know that pod is a process that is running on a virtual machine. So that means that it can have access or it can have privileges. So you can control those privileges and access. For example, you can say that I don't want to run it as a root user. I want to run it as maybe some user group. I don't want to allow the privilege escalation part, so that it doesn't get those privileges escalated. And also, I don't want to provide any Linux capabilities because they might not be required for your applications. Or in some cases, there might be some required, then you just provide those many capabilities there. But the whole idea is most of your applications, they will be, for example, traditional Java, .NET, or JavaScript, or maybe some other or Python applications. They do not need these kind of capabilities. They are basically focused on their business use case. So it's better that you intentionally declare in your pod, in your deployment, that you are limiting all those capabilities and access so that you are always running a secure application. Yeah. So here I want to talk about the secrets. We know that in the Kubernetes world, the secrets are used to store the confidential information, which is fine. But as a start, I would recommend that if you have some service bindings, for example, if you are consuming some BTP services, always use the service bindings because then they automatically create a secret which you don't need to manage by yourself. So they will always store the create a secret, and then you can simply use it in your application. And in case you delete the service binding, the secret is also deleted. So that way you are not managing the lifecycle of secret by yourself, which is quite great because that means that you don't need to worry about any security aspects for that. But in case you need to use a secret, please use it, but ensure that you are not making it a part of some source control because then you are essentially hosting it in the source control, which is a bad idea. It gets exposed to unintended personas, and you should always avoid it. So the practice would be that in case you want to create a secret, always go and create a secret directly in the dashboard or maybe via the kubectl command, yeah, so that you do not store any static information about the secret somewhere else as a file or something like this. So they from the BTP side, there are alternatives like you can use something like a SAP Destination Service or SAP Credential Store Service, and you can consider using those for storing your credential information. That's like the other alternate. If it's possible to use it, you can always consider using that. Okay, so that's mostly about the secrets part. And now we can talk about the governance and the role-based access control. So the first thing is basically to understand who are the administrators of your Kyma runtime. So whenever you provision a Kyma runtime, you will be giving this kind of a configuration when you are starting provisioning it. So basically you'll be telling like what is my max and min autoscalers. That's fine. What kind of a YDC I have. So by default, it will use a default one, or you can provide your own, for example, SAP Cloud Identity Service client or tenant or something else. That's also possible. And along with those informations, you will also be providing the list of the default administrators as a list of the email IDs. So in my case, I'm providing my email ID there. So that means that by default, when Kyma gets provisioned, there is only one administrator, which is currently me, who created the cluster. So you can see here that it creates something called the cluster role binding that has this particular email ID here. So that's fine. That is all good because that means that I have all the access. I have the cluster admin access to the cluster which I provisioned, which is like what I intentionally wanted in the first place. But then the next question comes that now if I want to give the access to my peers, my developers, so how should I do it? Yeah. So maybe let's do a bit of like on the cluster side, we can do a bit of a demo there. So what does it mean there? So I can go back to the cluster details. So what you can do is, so in case you want to give another admin, another developer an admin access, you can create something like another cluster role binding. So you can provide it something like a name. So you can provide a colleague access, and then you can select the role. So in my case, I will select the cluster admin because I want to have admin access for that. So in this case, I will say the kind is a user, and then yeah, I'll just provide the email ID there. The main thing to note is that this email ID, it should have an account on accounts.sap.com. Otherwise, it will not work. Yeah. So this behavior might change later on, but for now, yeah, it requires the accounts.sap.email ID account there. But you can see the behavior changing there. But that will be irrelevant than what we are doing here. That will still stay the same. So this is how when you create a cluster role binding, so basically you are uh, binding a role with a particular user and telling that or granting the access to that particular user. So that's how you can grant access at the cluster level. But that's not something that you always want, because not every colleague is going to do the admin operations on your clusters. There might be some colleagues who are just developers. Then they do not need the whole access to the full cluster. So for that, you can always give a role binding or create a role binding at the namespace level. So you can always go to a particular namespace. Maybe let me just go to this example namespace. And here in the configurations, I can create something like a role binding. So I can again create a role binding here. So something for my developers. And here again, you can select a kind of a role. So basically, role is nothing but a group of permissions, like what all actions they can do. For example, can they create deployments? Can they update deployments? Can they create services and things like those? So either you can create your own customized role, or you can choose one of the roles that best fits with your requirements. So there are like multiple roles defined out of the box. In my case, I will again can use the cluster admin role. Now, this is interesting. I'm saying cluster admin, but it is in the context of this namespace. That means that it can only do all the operations that are admin operations that are a part of this namespace. It cannot do operations outside the namespace. So that's kind of really easy for me, because then I don't need to customize the role. I can simply say that whatever admin permission you want, you can basically use it from there. But in the end, you won't be able to do anything to a different namespace, for example, to another namespace where you're not supposed to do anything. You can also use something like a namespace admin. So that also has a very similar set of permissions. You can look in details exactly what basically what permissions they differ in, but essentially they more or less serve the same purpose. So I can basically give my developers the permissions to everything in that particular namespace. So that's also something that I can do. So that's for the developers, like how you can give them a fine-grained access based on what kind of requirements they have. By the way, if you are interested about the roles, like what all they can do, you can always come here and you can check that what is a definition of a role. So I can go back to this one in the cluster roles, and here you should be able to, for example, see the namespace admin. Yeah, so for example, what does this namespace admin entails, what all permissions it has. So you can see that, okay, what all things it can work on the subscriptions of the operator, it can work on these many APIs. So it has all the permissions for various resources. So it's quite long, but essentially you can see that what does it mean. So I can work with these resources. I can do get, post, read, what kind of operations are required there, and then based on your setup, you can always configure or create your own roles also. For example, if you want a developer to only maybe create and update the deployments but not the services, then you can create a custom role, something like this, and then you can assign that role via the role binding to that particular developer. So that's also possible. So that is for the developers, for the humans. Now the question comes, okay, this is all fine, but my CI/CD pipelines, they are not humans. They are machines. Now, with the developers, there is always a login process that is a part of your Kyma access. So for example, if I am going to access this cluster in the incognito mode, maybe you might see the login process in action. So you see that yeah, there is nothing, no cluster connected. So I might need to download it here. Okay, I'm going to just go connect. You see that there was a small SAP authenticated process. So basically it is authenticating against yeah, my credentials and then doing a login for me. But a CI/CD pipeline like a GitHub Actions or SAP CI/CD service or some other tool, they cannot do this human login, or they don't have this kind of a laptop with credentials that can do the login for them. So there is no manual process there that they can intervene. So for them, this kind of a setup will not work. That is where they can use something like a service account. So what you can do is, just to give an example, I'm going to one of these namespaces where I have already a service account. So here you can create something like a service account. So think of service accounts as basically machine representative users. Yeah, so they are not the actual users, but they are basically the users that have this machine kind of access. So you can think them as the users for machines. So here, for example, you can create a service account, and then after that you can create a role binding for that service account. So for example, here I might have created this role binding. So you see that this service account prod SA has a in the namespace has a role binding to the prod RB, and then it has a access for the Kyma or the cluster role Kyma namespace admin. So again, I'm creating this role binding for a service account so that it can do all the actions in this particular namespace. So once I have done that, that means that this service account is now a mechanical user, a machine user that can do all the actions there. And after that, I can always go back to the service account and then download the kube config for that. So if I go to the service account there, I can always download the kube config. And this kube config, then I can then use with my CI/CD pipelines. So please remember to use these kind of kube configs only for your machines, but not for the user, because for the users, you always want to ensure that there is a proper login process in place. So for example, if your developers or your peers change teams or they leave the company, you don't want them to have this full access every time. So these kind of access is meant for the machines, and the normal users, they should use their login process. So that was pretty much it. I will go back to the presentation. So we already talked about, I think, these parts. So talked about the users, talked about how to restrict the access so that you want to only give it in a particular namespace. And then for the machine, we also talked about what is a service account and what does it mean. So that was mostly about the whole governance part, how you can do a role-based access control inside a Kyma cluster. And last part that we want to touch about is how you can stay up to date. So basically, if you are interested in what's a new feature coming in Kyma, what kind of changes are coming, do I need to take some action from my side? Do I need to update my configurations in case a particular API version is going to be deprecated or things like those? So that's where you can use various resources that we provide out of the Kyma side. So the first one and the foremost is that there is a section called What's New in SAP Business Technology Platform. And here you can always filter it out by the Kyma runtime. So you can always select a component as Kyma runtime, and then you can see the various upcoming new releases, new improvements being listed here. And then you can see that if something's affecting you or you need to take some action for your workloads or your configurations. So that's like the first and foremost piece of reference that I will always use. Apart from that, in case of you can always subscribe to these cloud system notifications so that you can get aware of any kind of problems or outages that can happen with the Kyma runtime services. The third one that's also very important is to keep an eye on the Kyma open source release notes. So whenever there is a Kyma open source version, a new version is released, after around 2 to 4 weeks, that gets applied to the managed Kyma runtime. So there also you have some idea about what is going to be coming next in my Kyma runtime that is being managed by SAP, so that you can take some appropriate actions on that part. But more or less, these are like the basic and very efficient ways to stay up to date so that you know what is coming and you know what action to take based on that. So that's mostly it that we have for today's section. Today's session, and then I hope that that was informative, and then would be able to help you in managing and working with your workloads and doing the day-to-day operations. Thank you. So that's pretty much it from my side.